By the end of this session, you should be able to do a few things. Number one, you should be able to understand what linear relationships means. What does linear mean? We'll spend some time on that. And what does correlation mean, especially in the context of linear relationships? We will explore simple linear regression models. I should tell you that simple here does not mean elementary. Simple here means one variable impacting another variable. We will then extend that to multiple linear regression, where there are two or more input attributes. So an extension of simple linear regression. We will evaluate these regression models within the context of understanding the model and interpreting it and using it to predict. And we will look at some applications as we go through this process. In this session, we will be discussing certain aspects of linear regression. Just to go into some brief details, we will be looking at the business problem and the solution space. What does this mean? It means that we need to take a business problem and then convert it into a mathematical model. That is what is meant by solution space. Within this mathematical space, a solution will be found which will be a mathematical solution to a business problem. This solution will be in the form of a linear relationship. What is a linear relationship? Briefly, a relationship of the form y is equal to a plus bx, but we'll see the details. This also links to the idea of correlation or the relation between variables. Because is that not what a linear relationship actually picks up? Simple linear regressions are what I just described, a relationship between one input and one output, between two variables, also called bivariate regression. It extends to multiple linear regression where there are multiple inputs but still a single output. Now, all this is done with a specific condition on what I am calling the output. And that is that the output is a number. It is not a label. It is a continuous variable. I'm also saying that the input is a number, a continuous variable. But what happens if the input is not a number, a label? For example, a region, north, south, east, and west. How do we deal with that? That is a study of categorical variables in regression. Once we have formulated what regression is about and we know what the models represent, we need to understand how a model is evaluated. This is not an easy question to answer because it means that we have to be clear as to what it means to have a good model. And that involves looking at some ideas in being able to predict using a model and being able to understand whether a model is doing a good job, possibly in other senses, such as, for example, how big a model is. So this will be our agenda, and we will systematically go through the various aspects of this.